Hey everyone, and welcome. What we're doing today is taking a look at the latest Next in AI newsletter and boiling it all down for you. We're going to give you that full 360-degree view of the entire AI ecosystem, from the actual chips that make it run all the way up to how it's shaking up businesses around the world.
All right, so this quote right here, this is basically the theme for our entire discussion today. It's the big idea we're going to unpack. It's all about this complex interplay between the tech, the business side of things, and, how society is dealing with it all. The key takeaway is that AI isn't just a list of new gadgets or models. It's a living, breathing ecosystem where everything affects everything else. So let's dive in and see what that actually looks like.
Okay, that sounds great as a big picture concept, right? A complex interplay. But what does that really look like on the ground right now? How does it actually work? To really get it, we've got to break it down into its core pillars. And we're going to start from the very foundation, the bottom of the stack.
And that brings us right here to our first section, powering the AI revolution, the foundation. This is the bedrock, the hardware, and the big ideas that make everything else you hear about in AI even possible.
So it really does all start with the hardware. I mean, these massive, super sophisticated AI models we're seeing now, they are unbelievably power hungry. They need just enormous amounts of computing power. And honestly, the demand for more and more of it is a constant bottleneck. This is exactly why the race to build better, faster, and more efficient hardware is just absolutely crucial. And you can really see this playing out on two fronts. On one hand, you have these incredible innovations, like NVIDIA's new Blackwell workstation GPU. It's a beast, designed specifically to help data scientists wrangle these just gigantic data sets. But then on the other hand, you've got this less flashy, but maybe even more important challenge: heat. Seriously, as we cram more and more power into smaller and smaller chips, heat becomes the single biggest thing holding us back. So this science of thermal metrology, which is basically just the super precise measurement and management of heat, that's now a huge deal. It's a critical frontier all on its own. Okay, so we've got the raw power, but that's not enough, is it? It leads to another really fundamental question. We can build these unbelievably complex models, but do we actually get what they're doing? Do we understand how they're reaching their conclusions? This, of course, is the famous black box problem in AI. And the key to cracking open that black box is a field called interpretability. And this is fascinating. A recent paper in Nature Machine Intelligence is pushing a new framework for this. It actually pulls ideas from the philosophy of science to create a more formal, rigorous way of analyzing an AI's decision-making. And look, this isn't just some academic thought experiment. In fields like biomedicine, being able to trust and understand the why behind an AI's diagnosis, well, that can literally be a matter of life and death. So once you have that foundation, powerful hardware and a way to start understanding what the models are doing, well, the research world just explodes with new possibilities. And that takes us right into our second pillar, the research frontier. And the pace of innovation here is just staggering. I mean, look at this. We're seeing everything from AI agents running high-energy physics experiments all by themselves, to new ways of fingerprinting audio to fight deepfakes. You've got AI inspecting building facades, multimodal learning for cybersecurity, the list goes on. The central theme you see over and over is a huge push toward more autonomy and better security. It really is like a Cambrian explosion of new ideas. And what's really interesting is when you step back from that flurry of individual projects, you start to see these clear patterns emerging. A ton of energy is being focused in three main areas. First, automating the process of science itself, which is wild. Second, a massive push in cybersecurity, both for defense and for risk management. And third, really defining how we as humans are going to interact with AI, everything from how we talk to them to how we can trust them. Which, of course, brings us to our third pillar. All this incredible foundational tech, all this cutting-edge research, it has to go somewhere, right? It can't just stay in the lab. So how is it actually translating into the real world and making an impact on the market? Well, we're seeing two huge trends happening at the same time. You can think of them as two sides of the same coin. On one side, you have companies building out the massive physical infrastructure that AI needs. A really fascinating example of this is NVIDIA and Emerald AI. They're partnering with energy companies to create what they're calling flexible AI factories, treating data centers like actual assets on the power grid. It's brilliant. Then, on the other side, you have the software tools that actually unlock the value inside that infrastructure. You're seeing new products like DataSieve 2.0 launching, designed to help businesses do one of the hardest things out there: pull clean, usable data out of all their messy, unstructured documents and text. Okay, so let's pull back and put all these pieces together. We've looked at the hardware foundation, the crazy research frontier, and the real-world business applications. How does this all connect back to that interplay we talked about at the very beginning?
The best way to think about it is like a flywheel. It's this powerful, self-reinforcing cycle. You see, new foundational tech, like better, more efficient chips, makes totally new kinds of research possible. That research then creates brand new capabilities that businesses can turn into real products and applications. And what do those applications do? They create huge demand and a ton of funding for even better foundational tech. See how it works? It's not a straight line. It's a constantly accelerating loop.
And that leaves us with one last, and honestly, one crucial question. This flywheel, it's spinning faster and faster than ever before. The progress is just undeniable, and it's incredibly exciting. But it also forces us to ask some really tough questions about things like governance, ethics, and strategy. As this powerful engine of innovation just keeps accelerating, maybe the most important question of all is, who's actually steering?